everyone, welcome to building your first game on the internet computer using DFINITY. My name is Ethan, and I'm going to be running this workshop today. But before we get started, a little bit about me. I'm a student studying computer science at the University of Maryland, and my favorite programming language is Python. So to get started, this is a little bit of an overview of what we'll be doing, and just give you an overview of what you'll be learning today, though. You'll understand what DFINITY is and the internet computer. You'll learn a little bit about a new language called Motoko, and you'll use it to modify a web app, and then you'll learn how to deploy your app locally and to the internet computer. So first up, we will be talking about what DFINITY is. So first, DFINITY is a not-for-profit organization that was founded in 2016. It supports the development of the internet computer, like I was mentioning, which is a blockchain that enables developers to build scalable web experiences. Some innovations in blockchain that are worth noting were in 2009, when Bitcoin was created, which uses blockchain to create a digital currency. In 2015, Ethereum is introduced, which uses smart contracts as a way to create these secure decentralized apps. And in 2021, DFINITY launches the internet computer, which revolutionizes the way that developers can host apps on the internet. So first, let's talk about what the internet computer is. So when we're developing web applications, we generally have to make use of a central provider to host it. You may be familiar with AWS, Google Cloud, or Azure. These are examples of that. And the internet computer seeks to change that by making development decentralized. And decentralized means that there's no middle company or organization. And this is all powered by blockchain technology. So a little bit to go a little bit further into the internet computer, developing on this means that there are, like I said, there's no dependencies on big tech cloud services like AWS or Google Cloud. There's no hosted web servers, no database services to wrangle with, and no worrying about firewalls or antivirus software. And it's a total alternative to what we would usually use. The way it works is it's composed of many nodes around the world running the internet computer protocol. These nodes or these node machines are combined to create subnets. So there's no internet computer server. It's being run collectively by everyone on the network. There's not one location that has the servers like a regular data center. And the way this works is that subnets host container smart contracts, which are interoperable, which means being able to exchange and make use of that information. And they're interoperable compute units uploaded by users that contain both code and state. Canister computations are fueled with cycles to pay for the data center processing power needed to run them. So software hosted on the internet computer is created by writing canisters, which contain WebAssembly bytecode and the pages of memory that it runs with. WebAssembly is an open standard that allows the execution of binary code on the web. We'll get a little bit more into this in the later slides. And developers can convert ICP utility tokens into cycles to fuel these canisters. And you can buy and trade ICP tokens in the same way that you can trade Bitcoin or Ethereum. And the way you write a canister technically it can be written with any language that can compile to WebAssembly, which is, like I said, is a low-level language that runs in browsers. But these languages include C, Rust, and Motoko, a programming language designed to support the unique features of the internet computer. And today we'll be using Motoko, which, if you're not familiar, is a typed language. If you're familiar with JavaScript or any other popular languages, you should be able to pick it up pretty easily. So today we're going to harness the power of the internet computer, and we're going to deploy an application to the web. We're going to be playing Reversi. You may know it as Othello. It's a simple two-player board game. And we have some starter code for you, which we'll be adding some functionality to with the Motoko language. So let's get started. In order to set up our environment, we'll have to do a few different things. We'll have to install Node, install the DFINITY Canister SDK, and grab the Reversi game source code from GitHub. And I'm going to do that along with all of you. So first, just talking about Node.js is an open source JavaScript tool that will help us to run our application locally and install software packages the app needs. And in order to install it, you'll need to head over to node.org. I already have Node installed, but if you don't have it installed yet, be sure to go to node.org. And if you think you might have already installed it before and you want to check, you can go into your terminal and type node -- version. And if you get a response like telling you the version, that means you have it installed. If you get something saying like no command node recognized, then you probably need to install it. I'm just going to double check that I have it installed on my computer, which I do. I have Node 16 currently running. So the next thing you'll need to do is install the DFINITY Canister SDK. And SDK is a software development kit, if you don't know that acronym, and it's a collection of tools that allow developers to use a framework or language. So when we downloaded Node, we installed the Node SDK, which allowed us to use commands that start the terminal with Node in our terminal window. Installing DFINITY will allow us to do some of the same, but for a suite of commands which start with DFX, which is runs the DFINITY Canister SDK. And in order to install this, you'll need to open a terminal window and run the following command, and then type Y for a yes to continue. So I already have DFX installed, and if you want to check that you have it installed, you can type DFX into your terminal, and if you don't get an error, that means it's installed. Or you can also do DFX --v, which should also work. So once you have that installed, like I said, you should run this command and then click Y. And also, I'm actually unable to copy and paste this since I'm in presenting mode. But if you are curious we want to look at the commands again, or you want to try and copy and paste it, these slides are available where you check in for the event. So if you go to the MLH community Discord, you should see I posted a link on how to check in for this event. And when you go to check in for the event, it should show you these slides, which have all of the commands in them, if I'm never going too fast or you want to go back and look at this afterwards. So next up, you want to verify the DFINITY Canister SDK. And so you want to open another terminal window and run DFX -- version and ensure that the installation was successful. So like I said, DFX -- version, and you should get 0.8.0. The next thing you'll want to do is get the source code. So in order to do that, you should head over to mlhlocal.host/internetcomputer-starter. And I'm going to do that along with all of you. And what that should bring you to is a GitHub repository. And what you'll want to do next is I'm actually going to switch gears here and share my screen instead of the slide so that you can follow along with me. Let's see. Cool. So now you should be able to see my screen. I'm going to pull this to a new window and see. So if you go to that link that I was just talking about, you should see GitHub repository. And in order to do that, to get it on your local machine, you can just hit code and download zip. And then after that, you'll want to go to your terminal, and you'll want to find where this file in your repository. In order to do that, you just can do cd downloads, assuming that it was in your downloads repository. That's where it is for me, /reverse master. And if you are unsure or this is not working, another way to do this, I believe, at least on the Mac, is to just go, like it's not working for me, you can just go to your downloads and drag it over. So I'm going to do CD and then just drag the file over. Oop, my bad. I didn't realize you guys were having some trouble seeing the window. It's my bad. Oop, whoops. Cool. So cool. So now that you can see that I am inside of that repository inside of my terminal. Next up, you'll want to run the npm install command. And what that's going to do is it's going to check all of the different dependencies, no dependencies that you might need for this project, and it's going to install all of them. So so you have to do npm install. So you'll see that it installed all of these different files. It found some vulnerabilities, but you don't have to worry about that for now. I have done this before, so I probably have had most of the packages that were necessary. But if you don't, you should run npm install. So next up, you'll want to run npm audit fix because like it says here, we have 8 vulnerabilities. And in order to deal with those, there's this command called npm audit fix. So I'm better run. And now you can see it says found 0 vulnerabilities. So now we're going to go ahead and explore the code. In order to do this, you can open your favorite text editor. I'm going to use VS Code. So, and I have the command line installed for that, so I can just do code dot. And I'm gonna close out the Git repository for now, and then move this over here. And then you can see that over here, I have all of the different files. And if I click on any of them, they'll show up in my text editor. So this code creates a multiplayer game, like I was mentioning, Reversey, and it uses Mithril.js, which is a JavaScript front-end framework, and Motoko to create the backend. Real quick. Oop. Cool. So next up, we want to explore the code, and you'll see that I'm actually going to switch gears here so you can see the slides because there's some useful information on them. So if you see here that the slides show that the skeleton of all of the files. So there's the source folder, which has Reversey and Reversey assets in it, as well as makefile and dfx.json, as well as webpack.config.js. So next up, now that you have all of the files in your text editor, our environment is set up, and now we can actually start running our web application and modifying it. So in order to get it started, you're going to want to go back into your terminal where you are inside of the web app, and you're going to want to run dfx start -- background. So what that did, if you were doing that on your end, it should say listening on HTTPS 0.0.0.8000. And no matter what kind of computer you're on, you should still be able to go into your terminal and run this command if you were following along and you did npm install, you installed dfx, and that you installed, and then now doing dfx start -- background. If you want to go back and look at the commands, maybe you join late, like I said, you can go to the link that I sent when I made the announcement in the MLH community Discord, and you can find all of the necessary slides which have all of the commands that I've been running. So if you you might get like a little permission pop up when you run that command. If just click allow, no worries about that. And then next thing you'll want to do is launch the Reversi game. But like I said, it should say listening on this port, and you can now, what you want to do is go to the make file, and you'll want to just run make install. And a make file essentially just has a bunch of commands, and when you run make install, it is going to initiate all of the necessary commands, likely for whatever's necessary for installing. So I'm going to go ahead and type make install. And now I'm creating a wallet canister on the local network. So now it's just doing all of the work that the make file says to do when you run make install. And this is what it should look like currently. So building canisters that we were talking about before, building front end. So like I was saying before, so you make install, the make file has a list of commands inside of it, and it probably has a list of several commands. And the first one is running is dfx canister network local create -- all. And so it's going to do that command, and now probably the next one in the make file under install is dfx build, and now dfx canister. So they're just basically allowing us to run several commands in a row. Cool. So now it looks like everything is complete. And the next step would be to so once it installs, you want to copy the canister ID and the value of Reversi assets. So if you look in your terminal, the canister ID should be this, which I'm going to just save in a notes file. And canister ID, which is there, and then we also need the okay, yeah, it's the same value. So as long as you have your canister ID, you can just save that to a note, and we'll use that later. So the next thing you'll want to do is go over to a new web page, and you want to go to localhost 8000 and go to / canister ID equals, and then that value that we just copied. And it said, could not find a canister ID to follow to, but we should be able to troubleshoot that problem now, because that was intentional. But you'll see that when we're hosting locally, we'll need two separate browsers. And firstly, you'll open a new tab and paste your localhost URL that we just copied. And you'll, let's see, let's try to troubleshoot what went wrong here. So you'll see that the UI canister for the local network is this value. And then it's installing the code for the canister reverse the assets with this ID. And then if you go to localhost 8000 / canister, CANISTER. Oh, that probably just shouldn't be capital. ID equals, yeah, there you go. That'll launch the game. So, like in every coding problem, there's always, sometimes you have an extra capital letter or an extra typo, and that causes everything to go wrong. So it's always important to, double check everything that you copy and paste and type into the URL. So the next thing you'll want to do is play the game. So we can put my name is Ethan and opponent name, call him Bob, and you should be able to play. But the play button does not work. Or I guess it takes some time to load. But if you then copy the URL from this tab, which has, my name and my opponent's name, Bob, and then you open an incognito tab, say new incognito window, and you go to it, you should be able to play the game as one person, and then in the other one would be the other opponent. So, just like a regular game of Othello where you want to select the you want to have all of the pieces on the board be your color. These are actually both Ethan. So let's see how we can change it to being Bob. And in order to do that, you'll want to I believe you should be able to just change the names here. So making the first player Bob and the other one Ethan. See what that does. So that brings me to this page. And then, okay, cool. So the next thing we're going to want to do is add some extra functionality. And in order to do that, we're going to have to change some things inside of the code. So the next functionality we're going to add is we're going to want to change the side of the board and display how many games we've played in total. And then we'll start by modifying some JavaScript to change the UI of our app. So like I mentioned before, you should have the JavaScript inside of the your text editor from before, and we can go ahead and make some changes to that to modify the board size. So in order to do that, you can head over to the source folder inside of your file, and then reverse the assets, and then index.js. And you'll see the play function, which I'm going to pull up on this side. So you'll see the game function, and there should also be a play function. Yeah, right here. And inside of that, you can see that the board size is defined, and we want to change it. So you'll see that lines 336 to lines 340 that creates a map of our options for our drop-down menu. Sorry, 328 to 331. It might be different depending on your text editor and whatnot. And then on lines 341 to lines 341, or where board size is defined, so 333. The slides are slightly different than what's on my machine. But so this sets the initial value of the first item, so making it 6 by 6. And then on this line, 334 to 337, this is where a controller for the drop-down menu, which stores the current selection. So it takes the size of the table and makes it so that it uses that size. So if we scroll down to the bottom on lines 473 on the slides, add code here, it should say. And there, you'll want to add some code, and which is, so what we're going to want to do here is we're wanting to add a mithril element, like we were talking about. This uses mithril.js, and we want to add this element to the UI. So in order to do that, we're going to want to make some changes to the form, and then do form.push, and then n, and then in parentheses, label dot label, comma, board size. And this dot label is going to apply the correct font and style from our CSS style sheet. If you go into the CSS, it should be in style.css, and we search for dot label. Yep, it should show you a font family and margin, as well as some other stuff that is going to apply the correct style to that area. So as you can see, I guess that was already here, or maybe I just typed it twice, but we don't need it twice. And then the next thing we're going to want to do is add a little bit more. So we're going to do another form.push, which is going to say form.push m select name equals board size dot input. So that value before that we select for board size is going to be found here. And then we're going to set value to be drop down menu control dot selection. And then the next value is going to be on input function of E board size equals e dot target dot value. And what this is doing is it's going to basically get the value of that is currently being used for the board size, and then display it in a drop-down menu. And then the next thing is to modify the board size. So in order to do that, we're going to head over to, I guess we can do it in the same section. And we're just going to write, it's actually going to be inside of the same function here. So board size e equals target dot value. And then we're going to add a little comma and then do on change e. So whenever e changes, do drop down menu control dot selection equals drop down menu control dot options at e dot target dot selected index dot value. And then we just have to close everything out from that by doing closing the curly braces, closing these curly braces, and then doing a comma. Let's see. I guess we don't need that for now. And then the next thing we're going to do is we're going to add the drop-down menu control map. So I guess we can actually, so that'll close the on change, and then this, we can do a comma, this, enter. So what we're going to do now is inside of these brackets, we're going to set the options for the drop-down menu and make a Mithra element for each one. So in order to do that, we do drop-down menu control dot options dot map, and then option. So for each option, we're going to map it to m of option key option dot value, and then value we're going to map to also option dot value. Oops. So zoomed in, sorry to see what's going on. Option dot value. And then we should not need that. And then that should close out the brackets, and then do comma option dot name. And then that should close out. Yep, and that should close out all of our brackets. Cool. And then the next thing you'll want to do is go ahead and run make reinstall after you do all of that. So I'm just going to do a run through because I know that was a little bit confusing of all the different commands that you should add. So, or go over with everything we just did. So you go through, well, like we said, we're modifying our board size because we want to play with a new version and we want to have a drop-down menu for it. So on lines 473, we went ahead and we added this form.push command, and this adds a Mithra element to the UI. And then the dot label applies our correct font, this dot label will apply the correct font and style from our CSS style sheet. I showed you this CSS style sheet, and where that is being pulled from. Then after that, we went and we added a select drop-down menu from the element. And in order to do that, we did a few things. So first, we set value to be the initial value of the selection, giving it kind of a default. And then on input, we say, it's called from when we submit the form, and we set board size to the current menu selection. So basically, once we have input, we have a function which takes in a value and then sets the board size to that value. And then after that, you go to on change, where we're going to add a little bit more, where we added a little bit more. And when we select a new value, on change is called again, which then changes the control value to the new selection. And then after that, we set the option for the drop-down menu and makes a Mithra element for each one. So, and then after that, which is where we left off, you want to just relaunch the app so that we can see our changes. So as you see, you'll relaunch the app and you'll refresh your browser and you'll see the new feature. It should say board size, and it should show you the different drop-down. And if you select 6x6 or 12x12, either way, it should show you this little grid of the size that you selected. So after that, on line 1 in the index.js file, you'll want to import our canister code. So when we tap play, we can call a function from the reverse canister, reverse.start, and so basically allowing us to use that code inside of the index.js. And in order to do that, you just type import reverse from this quote //declaration/reverse. But we want to understand where this code is actually coming from. So, and then what it is coming from is the dfx.json. And you'll see there that we define two canisters, reverse and reverse assets. And inside of reverse, we have main, which brings us to the main.mo file. And then we also have reverse assets, which has some dependencies, some front end stuff. We don't even necessarily worry about that at the moment. And if we navigate to main.mo, we can see that on line 184, we have the public function start and the same function we called from index.js. So we have this function, it's called shared, and it takes in a message. And when we deploy our canister, these public functions become ways to read and write the data to the canister. So now that we've learned about sending data to the canisters, we can dive a little bit deeper. We learned that we can write public functions on our canisters, and we then use a front end like our JavaScript call to call them. So by doing this, we can send and receive data from our canisters on the internet computer. And then to add a little bit more functionality, we now want to store how many games of reverse we've played by incrementing the count when we start a game. And in order to do that, we'll use some Motoko. And in your main.mo or mo, in your code editor, head back to that file. And part of the start function is to call add game, and another function that is defined on line 267. So let's check out that. You'll see that the add game function creates a new game object with data passed into our app, like player IDs and board size. And every time we call add game, we want to increment the player's game count. So how do we do that? We need to use a counter, and we need to use player's data that is stored in the player state object. So if you head over to types.mo, it's in the same folder as main.mo. And let's take a look. In a simple object that allows us to store a name, score, and games count, we have the type player state. And like I mentioned again, we have a string that represents its name, and then another variable called score represents their score, and another variable games played, which represents the amount of games they played. And then after that, we can head to line 267, where we'll create a new function that will basically update games played after the player initiates a new game. And this is the function that we're going to add there. As you can see, It's a function that loops through the player's state, and when we get the player, we update their games played to be the absolute value of games played plus 1. And then the next thing you want to do is increase the game count. So, and actually call our function to do that. So in order to do that, we'll look up each player name in storage, and if it's valid, use it in set games played function we just wrote. So we'll do set games played option.chain black name comma look player up by name. And what this is doing is it's trying to collect the black piece player's name, and then also for the white piece player's name. And if it exists, then it's going to update, or it's going to set the amount of games they played, but likely increasing it by 1. And then once that is all done, we can go ahead and run make reinstall once again. And doing this, like I said, will run the same commands from before and allow us to see how it's working in our web browser. And like I said, if I was going a little bit too quickly, you can go ahead into the MLH community Discord, where when I made the announcement for this event, there's a check-in link. And in that link, once you check in, you should also see all of the slides that I went through, and it has all of the code. So now you'll see that our app has some new functionality. And what we want to do now is we want to launch it to an internet computer, like we were talking about before, which is, the blockchain cloud provider. So far, we've made some modifications to the game, and we have run it locally using by going to a web browser and going to localhost. But now we want to go to the internet computer. And in order to do that, there's 2 things you'll need to do. One of them is to get some cycles to charge our canisters, and the next thing it will be to launch our canisters to the internet computer. So our canisters are consuming resources when they execute code and read and write data. These resources translate into literal electricity, and so they have a cost, and we call these unit cycles. And then in order to deploy our code live to the internet computer, we're going to need some cycles. So in order to do that, thankfully, DFINITY has created the Sile faucet. In partnership with Fleek, this allows us to claim some cycles for free, and this is enough to get our application running. So I've already actually claimed these before, so I won't be able to do it now, but you can go ahead and head to faucet.dfinity.org, and you'll want to say connect to GitHub and log in with your GitHub account. And if you don't have a GitHub account, you'll need to create one, but it should be really quick, just entering your email. And then, like I said, you'll only be able to claim cycles for GitHub account once, which is why I'm unable to do it right now, but it's okay. In the future, if you want to use DFINITY, the credits are definitely affordable. So now let's add your device identity to connect the cycles to. And we want to head back to your terminal window and type DFX identity get principal. And what that's going to do, it's going to give you a value that you want to paste into your web browser. And that command again is DFX identity get dash principal. And then once you have that, you can go ahead and create a new wallet to store our cycles. So tap cycle wallet, and then tap generate new cycle wallet, and then continue. And after a few minutes, it might take a minute or two. You'll see that it says you have 15 TC, or just $20 worth of the cycles. And TC here actually stands for trillion cycles. So those zeros are hard to keep track of. It definitely is prettier to just leave it at 15. That's why it says that. And then after that, you'll need to transfer the wallet. So in order to do that, you'll need to do that so you can use it in our reverse canister. So you'll want to go ahead and copy the DFX identity command to your terminal, and it should be available here. It should have the wallet ID, and it should actually put your wallet ID into the command line here. So you should be able to just copy and paste that command and run it directly. And then it should say setting wallet for your identity default network IC to ID, and then your wallet ID. And then you can use DFX wallet command to check your cycles balance. And then you can lastly take your game to the internet computer. So in order to do that, you have to just check your connection with the internet computer. And you can do that by just doing DFX ping IC, and it should give you some response here. And that should be working with your setup for the IC. So after you do that, you can just do the command dfx deploy -- network IC, and this is going to deploy our code to the internet computer. And your output should give you another canister ID, this one for your deployment on the internet computer, the previous one being for your local machine. And you want to copy that value again, and then you want to paste it in your browser, followed by .raw.ic0.app. And then after that, you'll want to after that, your app will be launched. It might take a few minutes, but you can go ahead to that URL. You'll see your web page, and your app is now running on the internet. But that is essentially all I have for you today. But to recap, we have the internet computer as a public blockchain that allows developers to launch decentralized smart contract powered apps on the web. The developers can use Motoko programming languages to write smart contracts called canisters. You can also use C and any other languages that can be compiled to WebAssembly, which is actually what is used on the internet computer. And then multiple canisters can be combined to create a hyperscale, which is an open internet service. And some next steps that you can do to continue your work with this is to try customizing the front end of the Reversi app to fit your own style. Like I showed you before, you can go into the style.css and maybe change some of the fonts, see which variables are changing which parts of the website. That's a great way to learn more about CSS and HTML. You can also explore the internet computer tutorials at this link, sdk.dfinity.org /doc/developer guide /tutorials-intro. So that we'll have a ton of different tutorials about how to do a bunch of different things with the internet computer. And then lastly, you can join the DFINITY developer forum at forum.dfinity.org, connect and learn from other people who are working on with a similar tech stack. But that is all I have for you today. I hope that you all learned a lot. And if you, like I said before, if you don't, or if you want to go back and like do this again or look at the slides again, it should be on the link that you used to check in. All of the slides should become available for you to have a resource in your future. But with that, I hope you all learned a lot today, and that's all I have for you. Thank you.